Hello, my name is Cory-John. My project is called Arbor Technics. I have designed a carpentry and ceramic school at the farm, as these are the main materials being studied at the farm. The farm is a digital fabrication research facility where students go and explore the boundaries of different materials. The farm is located in Lacey Green. This is my contents page showing my chapters in this presentation. Chapter 1, Material Research. Here is my manifesto from the point of view of birch ply. It discusses how the ply wants to go back to its former self, like the tree, free and flexible, yet strong and proud, as it is an engineered timber that we predominantly work in today, what takes away the unique qualities of the material. Thus, I intend to find a way to bring these qualities back. Then I started looking at the making process of ply and how this affects the unique qualities of the material. Then I started looking at how to bring these qualities back, namely the flexibility. I felt that kerf bending was an effective yet rather beautiful way of bringing these qualities back. Chapter 2, Scale Model Testing. Then I started to test different patterns of various cut thicknesses and distance apart, investigating how it would affect the structural stability as well as the flexibility of the material. I found that smaller cuts closer together were more optimal than larger cuts further apart, i.e., more cuts per surface area, the better. Due to the instability of kerf bending, I decided to combine it with waffle structure in order to give it a sense of rigidity. This was my first experiment testing the two. I also explored ways that the length of the board could affect the design process. I also found that at this scale, you would need 25 mils in order to make a right angle. However, 30 mils is more optimal. I also explored ways in which I could make it into a column. Chapter 3, One-to-one testing. I first tried kerf bending the same pattern I had been using for the scale models, with various lengths in order to optimally achieve a 90-degree bend and find the ideal diameter. However, due to the thickness of the board, this did not scale with the scaling of the board and was not the optimal pattern. Then I tried a one-sided kerfing pattern and determined a mathematical formula for working out the number of cuts based on the blade thickness and the thickness of the material. I then moved on to one-to-one testing model. My first prototype failed due to the length of the lever arm from the joint, as the joint is naturally springy and wants to spring open. Thus, where the lever arm was so small, it bent out of place for the joints to be connected together. However, I then did move the joints further apart, and this allowed the model to work perfectly. I then tried with a different material and added another joint to the top and bottom to see if I could make the joint more stable. However, this was not successful. Chapter 4, the rules. From these prototypes, I determined that there is a set of rules with my system. The number of cuts you need based on the blade thickness and the material thickness. You need so much space for the kerf bending joints. The cross-lap joints need to be so far apart from the kerf bending joint, and you can only fit so many on a board. These are all the variations you can have. It is also a rule that the cross members are not a traditional cone-like structure due to the way the kerf bending goes across multiple cross members in multiple directions. It causes the cross-lap joints to be alternate sides when needed. Chapter 5, Spatial Analysis and Conceptual Design. I started looking at spatial diagrams of learning spaces. I started with this diagram of a library and its spatial requirements and how people move around the library, and looked at creating my own space with a library that conforms to the human body. From my analysis of my diagrams, I developed my own spatial needs that I then applied with my language to design a library, with the initial concept of a central meeting area and quiet reading spaces spread out where appropriate. The space conforms to the human body through kerf and furniture that comes out of the architecture. Chapter 6, Site Analysis and Initial Concept of Project. The farm is a research facility, fabrication workshop, and living workspace for architects, artists, designers, and those interested in materials. It is quite a unique place as students can come and stay there for a week or so while working on a project. When they are there, they can work on one-to-one prototypes or scale model prototype, but you must make something while you are there, as it's part of this fantastic experience where students can come and test their ideas. Then I looked at the road structure of Lacey Green and found that the farm was on a primary road, which makes it an ideal spot for the project. Then I looked at what was on the farm and identified 4 buildings that were not in use. I determined this is where I will build the project. I looked at the 2 main entrances and determined the more northern one would be better for the project. I then looked at shadow diagrams and felt that this area of the site, the courtyards and the spaces between the disused IT building back of the farm workshop, was always in the dark in winter. I believe that getting rid of this disused IT building and opening up the space would greatly improve the space. Then I looked at the layout of the farm and identified that the courtyard was a choke point for the whole farm, as it was a central location where everyone had to pass through. Then I investigated what rooms were comfortable and what rooms were uncomfortable. I found that the 2 choke points of the farm were the 2 most uncomfortable rooms. I determined that closing up this space would make the space more comfortable and connect the whole farm together. And then I investigated what rooms were used for storage of models and what wasn't. I found that almost every room was used for storage and that the farm needed more storage and better storage space. From my analysis of the farm layout, I then formed my own ideal layout of the farm, where the work life and home life are separate but connected. And I'm going to convert the existing into accommodation. From this, I developed my initial concept of the plan. Here is a conceptual drawing of the project. Chapter 7, Program. This is the program of the farm. The main entrance gives a sense of arrival and has a unique light quality, as well as views from various courtyards where models are on display. I've converted the existing farm into accommodation, and I've also proposed an extension that will connect the accommodation together, making a far more comfortable space. The workshops are connected by a covered courtyard with necessary facilities coming off of them. The delivery and storage bay is located to the northwest, and the library is placed to the southwest, with views through 3 courtyards framing the view. Here is a plan diagramming out the different construction methods in my project. Here is a diagram showing the movements of a timber student's first day. Here's a diagram of a ceramic student's first day. Here's a diagram of an average student's day. Here is a diagram of all the students' day at the farm. Chapter 8, Wall Structural System. I developed my wall systems through case studies. I first looked at this case study in terms of how they laid out their wall system. I determined that it consisted of openings and solids, glass for the openings, and reflective and timber for the solids. What I liked about this project is its materiality, as well as its quality of light. However, I did find it too repetitive, and the timber was only on the inside. From this, I developed my own system, first looking at the quality of light and materiality. Then looking at how I can expand this. I also found this system I could control the quality of light in the workshop, as too much direct light is dangerous in a workshop environment as it casts too harsh a shadow. I also found ways I could bring the materiality back into the system. Here is a 3D illustration of the wall system. This is how I developed the structural system for the main entrance, starting with a grid, then deforming the grid, then taking parts away in order to create a certain light quality and grand gesture celebrating the farm. I took a similar approach when developing the structural system for the library. However, I did not deform the grid. Instead, I took parts away and then took further parts away in order to make openings for accessibility. This gives a different light quality to the space. I also have this structure forming windows in the conventional parts of the construction. Chapter 9, Main Entrance. Here is a view of when you first enter the site. The landscaping gives a sense of arrival as the landscaping responds to a grid that aligns with the grids of the structure of the buildings, as much of the landscaping is made out of my system. Here is a view of the main entrance. It is a grand gesture that gives a sense of arrival. Here is an internal view. It is the reception and display room. It utilizes my system by allowing light in on all sides, as well as acting as storage and display for the models, showcasing everything that is great about the farm and gives a window into previous projects undertaken at the farm. The system also allows views into various courtyards. Here is a 3D section of the space. The glass walls allow lighting to the space, as well as allowing views through various courtyards, enticing people to explore. The roof is a green roof. This is the RCP plan for the main entrance. There is light coming in over each of the display cabinets, as well as just in front of the reception, as light will be the first thing you see when you enter the building. There are both timber and reflective panels similar to the wall system of the workshop. Chapter 10, Workshop. Here is an internal view of the space. The tall ceiling height and sawtooth roof structure allows the space to be used for the construction of large models, as well as to let light into the space. The south and north sides of the space are made of my infill system. The east and west walls are traditional construction, with my timber system on the inside to allow the walls to be used for storage on lower levels and display on higher levels. This is a 3D section of the workshop that shows the sawtooth roof structure that helps give it its lighting quality. Chapter 11, Courtyards. The development of the courtyards and display areas came from case studies. First, I looked at the John Soane Museum and how they displayed their artifacts. Then I created an illustration of how the John Soane Museum displays their artifacts. Then I diagrammed out the rules. Then I looked at how the farm displays its models and made an illustration of it. Then I diagrammed out the rules while comparing it to the John Soane Museum. Using these 2 illustrations, I created my own illustration of how I display models. I diagrammed out the rules. Mainly I'm using larger models as centerpieces and making the farm displays more organized. Here's a view of the central courtyard. You can see the rules such as the centerpieces and shelving for display of models around the courtyard. The landscaping also bleeds into this space with the planters that also aligns to the grid. This is a space for students to explore and relax during their break. Chapter 12, Library. An external view of the library, displaying the unique structure. Here is the same view at night, showing the unique lighting with the interior lighting. An internal view showing the quiet reading spaces and quality of light of the space. The internal walls come up to the ceiling to support the roof, as well as acting as furniture for the space. This is a true representation of my language. This is the RCP plan for the library, similar to the RCP for the main entrance. There are both timber and reflective panels, and there are also glass in key areas to light up the space, and small roof lights to give a kind of dappled effect to the lighting. Thank you. My name is Cory-John, and this has been my project, Arbor Technics. You may find more of my work in my portfolio, such as my one-to-one prototype, which was used as shelving for DS2.